What's up guys, I'm Eric here. In today's video, I'm gonna take a look at wireless serial communication. We can send and receive data using UART, but we don't know how fast we can use it. Sometimes when we create an experimental environment, we have to connect with PC and transmit data. If we can receive as much data as possible at the fastest speed, it'll be very helpful for the experiment. I'm gonna do a simple test. Let's look at the available maximum speed and maximum size that can be sent at a time to the serial port on the ESP32. If you don't need this part, you can move on. I personally wanted to find out about it, so I took this opportunity to proceed with this. As you can see here, a wired connection between ESP30cam and Android phone is allowing real-time images acquired from ESP30cam to be viewed in the mobile app. This is gonna be interesting. Let's find out the basics of using UART and do some analysis first. This is the starting point of this project. When searching for the maximum UART speed of ESP32 at Google, the search result is 5 Mbps. Not bytes, of course, it's bits per sec. Looking closer, ESP32 mode seems to be able to send and receive data at an incredible rate of 5 Mbps with UART communication. However, ESP32 commands is not a typical development environment, so I won't deal with this. Just what I can see here is that internally UART can have a maximum speed of 5 Mbps, that's all. And then if we actually wire the ESP32 and other devices to communicate via serial, at what speed can we transmit data? The USB interface is usually used the most when connecting between MCU and PC or end devices. The MCU's UART is not directly connected to the PC, but it goes through the serial connector. Various interfaces exist on the serial connector. It can be USB-C type or micro USB based on USB to TTL. It used to be mostly RS-232 and is still used in the industry. What you need to see here is the maximum transmission rate supported by this serial connector. Today I'm testing with two devices. These are ESP32cam AI Thinker and TTGOT Camera Plus. Each has a different USB to bridge chip and maximum transfer rate is different, so I think we can compare those hopefully. First of all, the TTGOT Camera Plus model used the CP2104 chip from Silicon Lab and the maximum UART speed is 2 Mbps. FTDI programmer used by ESP32cam used FT232R chip and has a maximum UART speed of 3 Mbps. How many bits will it send for 5-letter string including a new line via UART? We've heard about the 8 and 1 for serial setting. 8 and 1 is a common shorthand notation for serial port parameter setting in asynchronous mode. That is 1 start bit, 8 data bits, no parity bit, and 1 stop bit again. This UART frame is the most common configuration for PC serial communication today. If you haven't modified your serial settings, it's set to default with 8 and 1. Let's say you send 5 letters of the hello string and the new line in the serial communication. 6 bytes will be sent, which is 60 bits. From now on, I'm gonna test if I can send data at the maximum speed. Here's the source code I used. When we send data, you need to determine the size to send data at once. We call this chunk. It's common to send data in the chunk unit. There is a maximum amount of data that can be sent at once, so you cannot exceed that. The larger the chunk unit, the larger the amount of data you can send at once, but it's also important to determine the appropriate size because it can take longer to transfer. If the receiver fails to digest one chunk, there may be a problem with data transfer streaming. In this project, the image data will be encoded in base64 and sent to the application. For the test, several chunk sizes have been determined as the size of the image that can be used in the ESP32cam. It's not important because it's all dummy data. I will explain about base64 in the next video. The test method is first set to the maximum baud rate. Continue sending the chunk to the connected device. In my case, my MacBook is connected to this TTGO directory without any USB hub. Since the chunk is the minimum size, I will find the minimum delay to prevent it from being cut off. When writing to serial, I need to add a new line for my test. This way, the receiver side will know where the end of the data is. You can make your own rule for the terminate signal. For testing, I'm using my serial test program. It's showing graphs so easy to analyze the current situation. Let's send hello first and see how it comes out. You can see that the transmit data is 6 bytes and FPS is 1 because it has a 1-second delay. Let's do a real test. The first dummy data is 7321 string length. I will send this value with a 20 millisecond delay. The length of the data is 7322 bytes sent because it's included a new line. The data sent per second is about 120 kilobytes per second. It takes about 90 milliseconds on average. A problem has occurred. If you look at the graph below, the length of the string that came in has changed. This broke the chunk because new data came in before the data on the sender was flushed properly. The length of data should be all the same. So the minimum delay time is required to send chunk stably. At this time, let me change the delay time to 60 milliseconds. This time, I was able to confirm that the data came in stably. Due to the increased delay time, the transmission speed has decreased, but stable data transmission is possible. The chunk size should never be changed because it's a minimum chunk unit. If you send very large data, you can set the minimum chunk unit first, split the data with this, and then send it. You can make the original data by assembling these chunks in order at the receiver end. I tested several times to reach the maximum transmission speed by increasing the size of the chunk and delay time. Let me show you my test result. I sampled 1,000 data for each chunk. Also, the results may vary depending on the test environment. The left one is the test result of CP2104. Its maximum transmission rate is 2 Mbps. In my test, about 1.4 Mbps was the maximum speed that could be used. Also, the maximum size that can be sent at once seems to be about 50 kilobytes. I couldn't use write to the serial port if it was more than that. The next one is the result of FT232R. Its maximum transmission speed is 3 Mbps, so I was expecting better results than CP2104, but it wasn't very good. What we also need to think about is the hardware specification of ESP32. Clock speed and memory can affect serial communication. I did this test because I wanted to know the largest amount of data at the maximum speed that can be transferred in a wired environment from ESP32 to PC. This test I did is very simple test. If you need more detailed information about UART communication, please check the other source. There's a lots of things we need to run and it's good for you. The next video will be about creating ESP32CAM and Flutter app to display images coming in real time from a wired environment. Then see you soon.